Let's talk about something we all take for granted pretty much every second of every day. We're going to dive deep inside our favorite gadgets to find a tiny, absolutely essential component that stops all our electronics from, well, blowing up.
Now really, think about it for a second. You're taking raw, chaotic, high-voltage power from the wall and feeding it into this incredibly delicate, complex piece of technology. What's stopping it from just turning into a very, very expensive puff of smoke? Well, it turns out there's this little guardian, a microscopic gatekeeper, standing between that wild power and the sensitive circuits inside your phone. And today, we're going to finally give that hero the spotlight it deserves.
And here it is. Meet the voltage regulator. The name might sound a little dry, but its job is, without a doubt, one of the most critical in all of modern electronics.
So here's the bottom line. It takes a messy, fluctuating, unpredictable voltage coming in and spits out a perfectly stable, clean, and reliable voltage going out. It doesn't matter if the power source surges or sags. Its entire job is to hold the line, no matter what.
The best way to picture this is to think of a giant dam. Raw power from a battery or the wall is like a raging, unpredictable river. The voltage regulator is that dam. It tames the chaos, and on the other side, it lets out a perfectly calm, steady stream that the city, or, the circuit, can use safely. And that control is absolutely non-negotiable. Why? Because modern computer chips are incredibly picky eaters. A CPU might need exactly 1.1 volts to work, not 1.2, not 1.0. Meanwhile, your power source is all over the place. A battery's voltage drops as it drains, wall power can spike. Without a regulator, our devices would be unreliable at best and just plain broken at worst.
Now, here's where things get really interesting. Engineers didn't just come up with one way to solve this problem. They developed two fundamentally different approaches, two competing philosophies for how to tame that electrical river. On one side, you've got the linear approach. This is the brute force method. It sees any excess voltage and just burns it off as heat. It's simple, it's clean, but it's pretty wasteful. On the other side, you have the switching approach. This one is the clever, hyperactive genius. It flicks the power on and off thousands of times a second to create the perfect average. Way more complex, but wow, is it efficient.
So you know what we have to do now, right? Let's throw these two titans into the ring for a head-to-head showdown and really get into the nitty-gritty of how they work.
The linear regulator strategy is, honestly, elegantly simple. Just imagine it's like a valve on a pipe that you're constantly fine-tuning to keep the pressure just right. But there's a catch. All that extra energy it's holding back has to go somewhere. And in this case, it gets turned directly into waste heat.
And the price you pay for that simplicity is efficiency. I mean, look at this. In a typical scenario, over a third of the power you put into a linear regulator is just gone. Poof. It's radiated away as heat that does absolutely nothing. Not only is that a waste of precious battery life, but now the device has to get rid of that heat so it doesn't cook itself.
All right, now let's look at the other contender. The switching regulator isn't like a restrictive valve at all. It's more like an incredibly fast faucet that you can flick on and off thousands or even millions of times a second. Instead of just burning off the extra pressure, it just controls the on time so perfectly that the flow averages out to exactly what you need.
So how in the world does that work? Well, it's kind of like a tiny high-speed bucket brigade. When the switch is on, it quickly stores a little packet of energy. When the switch flicks off, it delivers that packet to the circuit. By doing this thousands and thousands of times every second, it all averages out into a perfectly smooth and consistent voltage. It's pretty amazing. And when you look at the results in the efficiency battle, it's not even a fair fight. A good switching regulator can easily hit 95% efficiency, sometimes even more. For anything that runs on a battery, your phone, your laptop, that difference is everything. It's the reason your battery can last all day instead of dying by lunchtime. So here's the final verdict. When it comes to efficiency and heat, the switching regulator is the undisputed champ. But the linear regulator has a secret weapon. Its output is incredibly clean. All that high-speed switching creates tiny electrical fluctuations. We call it noise that can interfere with really sensitive electronics. For that stuff, the simple, quiet, clean power from a linear regulator is priceless. Okay, that was a lot of technical detail. But let's bring this all back to the real world. Why should you actually care about any of this? Because this engineering choice impacts the devices you rely on every single day. This is the key takeaway, right here. Your smartphone is absolutely packed with switching regulators to squeeze every last drop of life from that battery.
They make our thin, powerful mobile world possible. But that high-end audio amplifier or that sensitive medical sensor, you can bet it's using a linear regulator. Because for those devices, perfectly clean, noise-free power is way more important than efficiency.
And that really is the story here. It's not a simple case of one being better than the other. This is a fantastic real-world example of engineering trade-offs. We have two different solutions that are both critical to modern life because they're each optimized for a completely different job.
And the scale of this is just staggering. We're talking about billions of these components sold by a single company in a single year. This tiny, unsung hero is quite literally one of the fundamental building blocks of our digital world, hiding in plain sight inside almost everything you own.
So that leaves us with a final thought to chew on. We all want our phones to be thinner, our batteries to last longer, our gadgets to be more powerful than ever. All of that pressure, all of that demand falls squarely on this tiny gatekeeper of power. The real question is, what will the next generation of this tiny hero look like to keep up with our demands?